Okay. Did you watch, Valerie, any of those videos?
No.
Almost none of them have sound.
I don't have this.
Oh.
I sent them to you.
I didn't have service, and I didn't get it back whenever I got back.
Oh, sad. Okay. Well, if you want to watch them, I'll send them to you. Okay, so remember that we've been talking about integrals. Okay, so the integral from a to b of f of x, what does that measure? The amount of what? Area, where? Between what two things? The graph and the x-axis. On what interval? A to b, right? Okay, so remember that the value of an integral is exactly how much space is on that graph. So, just like we did...
Good afternoon, Berkner High School. Freshmen, teachers, and freshman students, please exit. Go ahead, we're doing our student assemblies. Please exit your room, head out to the auditorium, out the front of the building. Please exit to the front of the building. Do not, and I repeat, do not exit through the fishbowl. Time, freshmen teachers, please release the freshmen and accompany your classes to the auditorium.
Okay, so if I wanted to find the integral from a to b, I would have
Bring
to...
your stuff, and then no food and drink is allowed in the auditorium.
And? No, nothing else. Okay, and then, so this would be my exact area, would be that shape. Now, remember that if it's a geometry shape, you can use any of those formulas. Okay, but if it's just like a random area like this, then you can't actually use geometry to find that. So, remember that yesterday, we would slice this up into pieces. Y'all remember doing this? Okay, and then what shape would we make? Don't make them, but what shape did we make yesterday? All rectangles. Okay, so remember, the problem with the rectangles was that you would always have like corners hanging off, and it was never that close to being right. So what they did later, they being like random, I don't know, mathematicians in history, is they said, well wait, what if we make a rectangle, but we make the top of it like a rooftop? Okay, so look, watch what happens when you do that. Instead of making a rectangle, connect those with a straight line. Okay, and then instead of making a rectangle, connect those with a straight line. And then here, connect those with a straight line. And then your last one, connects them. Now, what do you notice about the area that you're missing? How does it compare to yesterday? Yeah, we have much less error, right? It's a lot closer. So if you kind of turn your head sideways, what shape is this? Okay, let me draw it out here. More exaggerated. What shape is that? A trapezoid. Therefore, trapezoid rule. Okay? So what you're going to do, okay, we're going to very shorthand our notes from yesterday, is you're going to divide into n subintervals. And then you're going to, instead of creating rectangles, you're going to create trapezoids. Then what are we going to find for each trapezoid? We're going to find each trapezoid's area, and then we're going to add all of those up. Find area of each trap. And then number 4, your last step, would be that your integral from a to b of f of x is approximated by area 1, area 2, area 3, blah, 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 depending on how many trapezoids you broke your picture up into. Okay? Okay, now, remind me, this is our little trapezoid here. How do we find the area of a trapezoid? 1/2. Okay, base 1 plus base 2 times height. Now, for this trapezoid that I shaded in here, which sides are the bases?
Parallel.
The parallel ones. So this is one of my bases. Maybe I'll do them in orange. Hey, how are you?
I'm ready to know.
Oh, okay. Thanks. All right, so this is my first base. This is my second base. Now, where is my height going to be? This part down here, right? Because if these are my bases, then it's like it's sideways. So instead of using this formula, I'm going to rewrite it like this. 1/2 y1 plus y2 times delta x. And the reason why is because it makes it a little bit more related when the trapezoid is sideways. So on my picture, for example, this would be y1, this would be y2. What would the next dot be? y3, then y4, then y5. So let's find the trapezoidal rule for this particular shape using our picture. So ready? My integral from a to b of f of x dx is approximated by, remember you have to use the squigglies, okay, because it's not exact, it's an approximation of that area. Now look at my little shaded in trapezoid. I'm going to do 1/2 y1 plus y2 times delta x plus. Now, that was my first trapezoid. This is my second one. I'm going to highlight it in orange. Okay, what are my bases for that second trapezoid? y2 plus y3. Delta x plus. Now I'm on my third trapezoid. I'm on this one right here with the little dots in it. Okay? Polka dots. Okay, what are my bases that I'm adding together on that third trapezoid? Good. 1/2 y3 plus y4. And then I have whatever the width is of that section. And then for my last trapezoid, what would my bases be? y4, y5. Very good. And then delta x. Okay? Now, that is the expanded rule. You have to do that formula if you have unequal subintervals. If you happen to have equal subintervals, okay, so this is for unequal subintervals. Let's pretend though now, kind of like I tried to draw my picture, that all of your delta x's are the same. So like you're going by 2 each time. What could you do if all of your delta x's are the exact same number and they're in every single term? Every single one has one. What could you do with it? Pull it out to the front. What else could I pull out to the front? The 1/2. So this is going to be if they're equal, you get to use a short version. So you would do 1/2 delta x, then set up a bracket for me. Now, okay, remember what we said. They all have a 1/2, boom, we pulled it out. They all have a delta x, boom, we pulled it out. What's going to be left over is all of the y craps added up, right? Okay, but think about there's a pattern. I would have y1 plus y2, what would come next? y2 again plus y3, what would come next? y3 again plus y4, and then y4 again plus y5. What are the only bases that only get added once? The first one and the last one. So to shorten that, we're going to do y1 plus double y2. And then double y3. And then double y4. And then only one y5. So your first and your last base only get counted once. But all of the middle numbers get to be a base 1 and then they get to be a base 2. So they all get to be counted twice. Make sense? Okay, so switch to your homework for me. I'm going to come around and check it at the end of the day, and then you never have to do it at home, because we're going to do probably all of it in class today. So look at number 1 for me, please. Am I good to take this off? Or are you still ready? So number 1 on your homework says R of t is the rate at which cars pass through a certain light monitored on a 3-minute timer for 15 minutes. Okay, then it's, what is R of t measured in? Cars per minute. What's time measured in? Minutes. So the first thing that it says is interpret the meaning of the integral. Okay, so think about, we talked about yesterday, you multiply the units together. So if this is in cars per minute and this is in minutes, when I multiply those together, what do I get? Good, cars. You'd have cars per minute times minutes. That would be cars. Now, what are the cars doing? They're passing through the light. And then when are they doing it? Look at your endpoints from 0 to 15 minutes. So, you would write your integral from 0 to 15 R of t represents the number of cars passing through the light. I'm going to abbreviate through. Okay, over 0 to 15 minutes. And then remember, okay, in case you didn't hear it when I said it a second ago, how do we get the number of cars? You multiply cars per minute times minutes. And what's left over is cars. That's what you're measuring. So the area you get is the number of cars that went through the intersection. Okay, now look at the big long sentence. Okay, it says, estimate the integral using a trapezoidal sum. So, first question you have to decide is, do we need the long rule or do we get to use the short rule? How do we determine? You have to look at your subintervals. What do we want them to be? Equal. Look at your table. Is it going up by the same number each time? Okay, what is it going up by every time? So your delta x is 3 and they're always the same. That means I get to use the short rule. So, remember your rule is 1/2 delta x, y1, you don't have to write this, double y2, double y3, blah, blah, blah forever, and then yn. Okay, that's your short version. You do not have to rewrite that, it's in your notes, but you can if you want to. So, for this question, I'm going to put my 1/2, what did we say our delta x is? Okay, 1/2, 3. And then I'm going to set up a big bracket and I'm going to add all of the y values twice except for which two? The first and the last. So you'll have a 20 plus a double 31, double 28, double 24, double 22, and then a 21. And remember that this method of calculating the integral is usually more accurate, okay, because it actually follows the direction of the curve. Okay, we're going to do 3 next. So go ahead and read through number 3, and I want you to take a guess at the meaning for part A. It says interpret the meaning. Remember, how do you do the meaning? What do you do with the units? Multiply them. So try to do part A. Okay, what units am I multiplying? Okay, good. Meters per second times seconds. When you multiply those, what do you get? Meters. And who did the meters? The car. Okay, so it represents the number of meters traveled by the car over what interval? 0 to 60 what? Seconds. Very good. So remember, you take meters per second times seconds, you get meters. Meters that are what? What the car traveled. Okay? Alright, oh, I didn't leave space to estimate it. I'm going to do it up here. Okay, next question. Same delta x or different delta x's? Okay, so we're going 0, 10, 20, 30, 40, 50, 60. So same. So that means we get to do the shortcut. So 1/2. What's my delta x? What are my x's going up by every time? 10. Big bracket. And then remember, the first one and the last one only count once. All the middle ones count twice. So you'd have 5 plus, double 14, double 22, etc. Make sense? Okay. Now, the second part of this question is actually review. Okay, so it says to find the average acceleration. Okay, so think in general, what's the relationship if this is velocity and we want acceleration? It's a derivative, and a derivative is a slope. Now, there are two kinds of slope. You can take the derivative and plug it in. That's called, so hold on, let's write this. Acceleration is the slope of velocity. And then there are two kinds of slope. You can do I-rock or you can do A-rock. Whenever you have a table, you have to do A-rock. And the reason why is the only way that you can do this is if you can take the derivative. And you don't have the equation to take the derivative. So sadly, this does not work without the equation. That means it has to be the average rate of change. Now, if I want the first minute, how many seconds do I want? 0 to 60. Good. So, if I want the average acceleration, also the average there is a hint, right? Average rate of change, average acceleration. Okay, then I'm going to find the velocity at 60 minus the velocity at 0 over 60 minus 0. What's the velocity at 60? 36. What's the velocity at 0? 5 over 60. Now let's think about our units. On the top, what was velocity measured in? Okay, this is meters per second. What's the time measured in? Seconds. So then what will our answer be measured in? Meters per second squared. Good. So you'd have 31 over 60 meters per second squared. 31 over 60 meters per second squared, and that would be your final answer right there. Okay? Alright, last question on here is also review. It says, how many times must the car have been going 38 meters per second? Okay, look at your table. When did our car have to hit 38? Good. Between 40 and 50, because why? Where does 38 fit? In between 35 and 40. Now, it says how many times. Is there any other interval we know that has to happen? Very good. Look right here. If it went from 35 to 40, it must have hit 38. And then to go from 40 back down to 36, it must have hit 38 again. So how many times? What's our answer? Twice. On what intervals? We said 40 to 50 and 50 to 60. So, IVT, I was going to ask you, what theorem is it? IVT, because remember, the I stands for intermediate. So, 38 is in the middle, it's intermediate. So, IVT guarantees this because 38 is between the velocity at 40 and the velocity at 50, also between v of 50 and v of 60. So you're saying, I know it happens because 38's between my velocity at 40 and 50, and it's also between my velocity on 50 to 60. And you could word that differently and still get your point, but make sure that you mention twice the theorem and then that 38 is between. Those are kind of like your key things that you have to make sure that you say. Okay? All right, go back and look at number 2. The hole punched number should be an 80. The hole punched number that's kind of like gone should be an 80. So if you want to scribble that in. Okay, so let's go ahead and do the sum first. So the integral from 0 to 90. First question, short formula or long formula? Why long? Because your delta x's are not the same every time. If they are, you get to shorten it up. But if they're not, you have to do each trapezoid on its own. Now, quick question before we do this. Is there at least one thing that we can take out from all of them if these are different? The half. So I'm still going to take out the half, but I can't take out the delta x. So put your 1/2 in the front, and then put a big bracket. Now, for my first trapezoid, okay, so we're going to go from 0 to 30. What are my y values that are going to be my bases? Pretend like none of these are even here. 20 and 30. And then what is the width of that x segment? If it's all the way from 0 to 30, how wide is it? 30 units plus. Okay, now instead of going 0 to 30, my next trapezoid is going to be from 30 to 40. Now, what are my 2y values for this particular trapezoid? 30 and 40. What is the width, though, between their x values? How wide is that subinterval? Only 10. So this is y2 plus y3, and then this is your delta x. Okay, next one, from 40 to 50. What are my 2y values? 40 and 55. And then how wide is that subinterval? From 40 to 50, how wide is that? 10. Next one is from 50 to the hole punch to 80. Okay, what are my y values that I'm adding together? 55 and 65. Remember, those are the bases of your trapezoid. And then how wide is the base if it's from 50 to 80? 30 units long. Very good. Okay, set up that last one. Think about it. You're adding your y values in parentheses, then multiplying by the length of the base. What are my y values? 65 and 70. And then how wide is the base? 10. And then close bracket. Now, if you would like to give everybody their own 1/2, that's fine. It doesn't matter. Same thing. Really, this doesn't save you that much time, but maybe a little bit. Okay, let's do our interpret. Okay, so what is in our table here? It says acceleration. What's acceleration measured in? Meters per second squared. What is time measured in? Seconds. If I want to interpret, what do I do with my units? Length times width. You're multiplying. So what is meters per second squared multiplied by seconds? What am I going to get for my answer? What? Will it be meters? Meters per second. One of the seconds is going to cross out, but are they both going to cross out? No. So you're going to get meters per second. What does that measure if this is acceleration? Meters per second measures velocity. So the integral from 0 to 90 of acceleration is going to represent the change in velocity in meters per second. So you multiply them together and then you're measuring how much that changed. So if it's meters per second, we measured how much the velocity changed. Okay, and then what am I missing from my interpretation? There's one other thing I have to add.
The time.
Okay, you could put the car in there, but what's also necessary is the interval of time. So you would say over 0 to 90. And then that's in seconds. So it would be the change in velocity. You could put change in velocity of the car, but as long as you have velocity in there, that's what's important. Okay, and then over 0 to 90 seconds. Make sense? Great. Okay, I think we only have like a couple more left. So we should be able to finish it. Alright, next one. Velocity of a car measured in feet per second is given by the function. Select values are in the table. First question. Set up an integral to represent the distance traveled by the car over the first 50 seconds. Okay, put an integral symbol. Remember, integral is the little squiggly thing. Where are we integrating from? What's our time? 0 to 50. Okay, and then what are we integrating? What's the name of our function in our table? Velocity. Now, remember that we talked about yesterday, I think yesterday, maybe the day before. Okay, if you want it to be distance, what do you have to change on your integral? Remember? Distance is always positive. Yes. Okay, put absolute value bars here. Now, on this particular question, if you didn't put the absolute value bars, you wouldn't have actually gotten in trouble. Okay, why? Look at your graph. It's always what? It's always positive. But if it wasn't, you would not get a point. So if it says distance traveled, remember that distance is always positive. So you have to put those bars there. And you'll never get in trouble for putting the bars, but you could lose a point for not doing it. Okay? Next one says estimate the value of the integral using a trapezoidal sum with the intervals in the table. Question, the same delta x or changing delta x's? Same. That means long or short? Yay, short. Okay, so 1/2 in the front. What is my delta x the whole time? My delta x is always 5. And so if that's the same, I get to pull the 5 out as well. And then remember the pattern that we said always happens. Which ones only get counted once? First and last. So I would have 0 plus, 2 12s, 2 20s, 2 30s. Plus, I'm going to put ... and then just kind of skip to the last few. Obviously, don't do that on the AP test. Okay, but I'm just going to jump to here. Okay, 2 75s, 2 60s, and then a 72. Now, do not do that on the AP test, but that table's like super long for no reason. Okay, what would I do next if I want to calculate the average acceleration and this is velocity? We just did it on the front. AROC, very good. Average rate of change over the first 30 seconds would be from 0 to 30. And then remember, a lot of times we'll put f of a and f of b, but you want to be specific. So here our function's not f, it's v. So it would be v of 30 minus v of 0 over 30 minus 0. What's the velocity at 30? 78. Velocity at 0 is 0, so I'm not even going to put that. And then 30 minus 0 on the bottom is 30. Think about my units. This is meters per second. This is seconds. Then what's my answer? Meters per second squared. Okay? We're gonna... yeah, we'll do this one. Okay, is there a time that a of t has to equal 0? Okay, now remember, this is velocity. What is acceleration in the graph of velocity? Slope. Okay, good. Now look at your graph. Is there a point where the slope is 0?
Yes.
Yes. Where? Describe it.
35.
Okay, at 35, because what does it look like happens? Your graph is kind of flat at that point, right? Okay, now you can't say that, you have to somehow show it. So here's how I would show it. Think about your slope. Before 35, what is the value of your slope? Is it positive or negative? Positive. After 35, what's the value of your slope? Negative. Is it possible for your slope to go from positive to negative without hitting 0? No. So that would be how you would prove it. So you would say yes at t equals 35. Before 35, a of t, the slope of v of t is greater than 0. But after, the slope is negative. Then it must have passed through 0, something like that. Because remember, you're not allowed to skip numbers. So if my slope was positive and then my slope was negative, then somewhere between that it must have hit 0. Because you can't skip numbers. Okay? Alright, next one. Okay, do part A, you're setting up an integral. Part B, you're estimating the value of the integral using a trapezoidal sum. We have an oil barrel that's leaking at a rate of R of t in gallons per hour. Values are in the table. What will my integral be? 0 to 15. What's the name of my function? R of t. And then notice that on this question, they're just telling you what it represents. But think about it. If this is gallons per minute, and this is minutes, or I'm sorry, pretend that's minutes. Okay, what would happen when you multiply? What would be left over? Pretend they're both the same. Gallons. So look, the number of gallons that were leaked, right? And so you should always think about those units here should match. Go ahead and make that minutes so that they're the same. Okay, so ready? Trapezoidal sum. First question, long version or short version? Short. Why? Because you have the same delta x. So it's going to be 1/2. What is my delta x? 3? And then remember your rule. You do the first and the last space only once. Everybody in the middle gets doubled. So you'd have 20 plus 2 31s, 2 28s, 2 22s, and 1 21. Okay. Go back to the sheet you were writing on just a second ago. We have to talk about one more thing. Okay. Do you remember yesterday how we were talking about like if it's too much area or not enough area? You remember talking about that? Yeah. Okay, so with these, it's a little bit harder to tell, but the way that you tell whether it's too big or too small is based on concavity. So if f of x is concave up, okay, I want you to draw a graph that's concave up, like that. Just pretend. Okay, there's our concave up graph. Now I want you to pick an interval. It doesn't really matter which one. I'm going to just go from here to here. And I'm just going to do one huge trapezoid so I don't have to do a bunch of little ones. My exact area is right here, right? If I draw in a trapezoid to estimate that area, how does the area of that trapezoid compare to the exact area? Too big or too small? My trapezoid is too big. So when you do a trapezoidal rule and the graph is concave up, your trap rule is an over estimate. And the reason why is because your trapezoid is going above where that concave up graph is. So, concave up, the estimate is too big. What do you guess is going to happen when we make our graph concave down? It's going to be an underestimate. So, draw a graph that's concave down. Pick any subinterval. I'm going to go from A to B right here. I'm going to shade my exact area, which would be this section right here. But now I'm going to draw in my trapezoid. And notice what happens. When I draw from here to here, my trapezoid is too big or too small for the actual area. It's too small. Area of trap is too small. Therefore, it is an underestimate. But remember, you're always comparing the trapezoid size to the actual area size. Okay? Yeah, sure. So now look at that one that we were about to do, and I want you to give your answer. Okay, so it tells you R double prime is greater than 0. So then you have to think about, okay, R double prime, that's concavity. If it's greater than 0, what's the concavity, up or down? Up. And if it's concave up, what did you just write in your notes? The trap is going to be an overestimate. Okay? So if R double prime is greater than 0, then R is concave up. And if R is concave up, then the rule is an overestimate. So for trapezoids, you have to check whether it's curved up or curved down. Okay, we have one question left. What type of rule are you asked to do in part A? A trapezoid? No, what is it? Okay, a Riemann sum is the rectangle one that we learned yesterday. Okay, so we're going to do a little review. Now, this one has a specific instruction that's going to change things. Okay, it says I want to use how many subintervals? 3. So, am I going to go 0 to 2, 2 to 4, 2 to 6, 6 to 8, 8 to 10, and then 10 to 12? That's 6. I don't want that many. So if I only want to do 3, from 0 to 12, divided into 3 parts, how long is each part? 4. Okay, so I'm going to say that one more time. If you're going from 0 to 12, divided into 3 equal parts, then your delta x needs to be 4. Does that make sense? Why? Because that's how long it is, and you're dividing it into 3 equal parts. So my first subinterval, I'm going to go 0 to 4, then from 4 to 8, then from 8 to 12. Now, also remember, if it's a left Riemann sum, who's going to get skipped? First or last? For a left Riemann sum, the last one gets skipped. So I'm going to do, my delta x is 4, and then I'm only going to add the left endpoint each time. So for 0 to 4, my left endpoint is 3. From 4 to 8, what's my left y value? 9. Good. Okay, and then from 8 to 12, what's my left y value? 6. And then remember, if it's a left, the last one is skipped. Last is skipped. Now, the second one asks you for a right Riemann sum. Who gets skipped on a right Riemann sum? The very first one gets skipped. So if it's a right Riemann sum, you're going to skip the first y value. Now, how many subintervals do they want on this next part? 6. So that means that what are you going to jump by each time? 2. So you're going to go, so this one you're not going to make big chunks. You're going to use little chunks. So from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12. And you'll notice that that's 6 different sections. What is my delta x? Still 4? No. My width is getting smaller because I have more rectangles. And then I'm using the left one each time. That means that the 5 down here never gets used. So it would be 3, 5, 9, 8, 6, 4. And then 5 never gets counted because it's never the left side. It's only a right side. Okay? And then last one is trapezoidal rule, long version or short version? Short. Why short? Your delta x is always the same. What am I going to put? Yes?
I thought in the right one we skipped the first one.
Oh, crap. Yeah, you're right. I did. I'm going to just make this a 5 sneakily. And he cut in line. He really goes like way over here. Good call. Trapezoidal rule. What'll I put? Ready to write whatever you say. 1/2.
Wait, why do we have 2 5s?
Because I had, remember I'm skipping the first one. So I had accidentally written a 3. So I crossed my 3 out and I took this last 5 and I just kind of let it go in the front. Okay, so half delta x. And then what do I do with my bases? Does anybody get skipped in trapezoidal rule? No, but all the middle guys get to be counted twice. So it'd be 3, double 5, double 9, double 8, double, what's next? 6, double 4, and then your little 5 on the end. How do we feel about this? Hard or easy?